Okay, today is 5.5, factoring quadratic expressions of the form ax squared plus bx plus c. The only difference between this and 5.4 is that instead of having a 1 as a coefficient in front of the x squared term, you might have a different number, any old number. And we're going to learn how to factor those using a lot of the skills that we have already mastered?
No.
Yeah, totally mastered.
Introduced. Okay, first. Let's look at the investigation that you guys have in front of you. And we're going to work through it a bit together. Sometimes I'm going to help you, sometimes I'm going to tell you to do it by yourself. So the first thing we're going to do is number 1, use algebra tiles to form a rectangle to model the product, yada yada yada. So you are well aware that when we're dealing with algebra tiles, right, we have factors, and in here is the product. What shape does the product take? What shape does the product become when we're all done?
Square.
Might be a square.
Or rectangle.
Rectangle. It's for sure a rectangle, right? So our product is always going to be a rectangle. You have to think of it that way. It's going to be super helpful for the rest of the investigation. So your goal is to use algebra tiles to form a rectangle to model the product 2x plus 1. So on either the top or the side, you're going to have 2x plus 1. And then the other factor is x plus 2. X plus 2. Well, let's multiply this out and get our rectangular product. We've got x times x, which makes an x squared. And we have another x times x, which makes an x squared. That's like doing first times first, by the way, if we're foiling. That's like first times first. Then we can do outside times outside, which is x times 1. Leaves us with 1x. And then we'll go inside times inside. So we've got x times 1. Well, x times 2, I should say. And x times 2. So that's like 2x times 2, which is 4x. And then down here in the bottom right corner of our grid, we have 1 times 2, which is just 2. So from that we can gather that 2x plus 1 times x plus 2 is what? So we've got 2x squareds, we've got 5 x's, and we have 2 1's. Now we've done this before. The goal of this is called distributing, right? This is multiplication. But the goal of today and yesterday, factoring, is going from the product back to the factors. Okay? So what we just did here is a little bit of review to get you thinking of the product as a rectangle and the factors as the side lengths of that rectangle, right? The side length of this rectangle is x plus 1, sorry, 2x plus 1 and x plus 2. They are the dimensions of the rectangle. The rectangle is the product. Okay, so this time, instead of going from the factors to the product, we're going to go from the product to the factors. Number 2 says, arrange algebra tiles representing the trinomial 2x squared plus 5x plus 3 to form a rectangle. So right off the bat, I can think of it, you don't need to draw this, you're going to draw the rectangle, but I'm just thinking, okay, it means I'm going to have 2 of these guys. I'm going to have 5 x's, so 5 sticks, 3, 4, 5, and I'm going to have 3 1's. Go ahead and take your time and try to figure this out and form them into a perfect rectangle. And I'll give you one really big hint. You want to start in this quadrant. You want to do this first, and then you want to do this second, and then you want to think about where your x's go. Okay? Hopefully that makes a little bit of sense to you. Go for it. Try your best to rearrange that into the rectangle, which is going to represent the product 2x squared plus 5x plus 3. Okay, so hopefully your grid looks something like the one I've drawn here. You have your 2x squareds in the top left corner, and you put your 1's down in the bottom right corner. And if you've done that correctly, your x's should fit perfectly in order to finish off the the rectangle. Mine is going to have 3 x's here and 2 x's down here. And as you can see, I now have a rectangle representing the product 2x squared plus 5x plus 3. And what this does is it immediately gives me the two factors, because the factors are just the dimensions of the sides, right? The dimensions of the rectangle, the length of the side. So here we have a side that has x and x, so that's 2x plus 1, 2, 3 ones, 2x plus 3. And down this side I have a side length of x and a side length of 1, so that's x plus 1. So we've just factored the trinomial 2x squared plus 5x plus 3, and factored form is x plus 1 times 2x plus 3. And again, you could double check your answer by foiling, and you should get the same trinomial. If all of the terms of the trinomial fit into this rectangular product, then you can't get it wrong. So the trick is to make them all fit as a rectangle. You're going to get 2 more chances to do this on your own, so you're going to repeat those steps for the trinomials in part 3 of the investigation. Those trinomials are 3x squared plus 5x plus 2 and 4x squared plus 8x plus 3. Go ahead and try those on your own, and remember, you've got a little bit of a grid. In the top left corner, you're going to put all your x squareds, however many you have. In the bottom, you're going to put your 1's, and then in these 2 remaining sections of the rectangle, that's where all of your x terms are going to go. See if you can get it to line up into a rectangle. Okay, hopefully your grid for A has been set up like this so far. I like to draw my x squareds all in a row. Again, I couldn't do it like this because that would leave a big gap in my rectangle. So I know that they have to be in one row, and then I like to draw my dotted lines to show me my 4 parts of my rectangle. Now I'm dealing with the 2 1's that are going to go in the bottom right corner, and I have 2 options for them. I can either stack them on top of each other, or I could do them beside each other. And it is important which I choose because I'll have a different number of x's each way. So let's first consider if I left it like this, I would have 1x here, and then I would have 6 x's in this box. I'd have 1, 2, 3, 4, 5, 6. And that would give me 7 x's altogether, but I only have 5 x's, so that is not what we want to do. So rather than stack them, I'm going to put them side by side and end up with an x there, and 3 x's here, which tells me that the dimensions of the rectangle, which are also the factors of the trinomial expression, are 3x plus 2. So I have a side length of x, 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 that's 3 x's, and a side length of 1 and a side length of 1, so that's 2. And the other one I have a side length of x and a side length of 1, that's x plus 1. So if I rewrite this expression as a product of 2 binomials, the 2 binomials are x plus 1 and 3x plus 2. How did you guys do on B?
Good.
Again, I'm
Missing
going
one x.
to... You're missing an x?
Yes.
Uh-oh.
I was too tired, but then
So one of the keys is, so I draw my x squareds right away,
Wait, you said you can't.
you can.
draw my box. As long as it's a box, you can do it.
Oh.
I'm not saying this is right, it might be stacked, but this is what I'm trying first. Okay? And then I'm going to put my 1's in, and again, my 1's I can either do down or across. Now in this case, it's actually not going to matter, because we have a perfect box here, so whether I did it this way or that way, it just swaps the place of these 2 things. But anyways, let's see how many x's we've got. We've got 1, 2, 3, 4, 5, 6, 7, 8. Good?
No, look at it. You have 3x.
And now we look at our dimensions. So we're looking at the side lengths. Here we have x and x, and then 1, 1, 1. So that's 2x plus 3. Here we have x, x, 1. That's 2x plus 1.
I see what you mean.
So 4x squared plus 8x plus 3 as a product of two binomials is 2x plus 1, 2x plus 3. And again, if that doesn't work, then you might need to do something different with these 4x squareds. Maybe they are all lined up in a row. It depends on what this middle term is and how many x's you need. But get your x squareds in, then get your 1's in, and check to see that you have the right amount of x's, and then you know your dimensions are the lengths of the sides. I just got asked the question, when will the rectangle be in the shape of a square? So when will our product, this one's a rectangle and this one's a rectangle, when will it be in a perfect square? And you can use this example. When what? When the length and the width are the same. When the factors are the same. So if you had, let's say, x plus 2 and x plus 2, okay? That would give you x squared plus 4x plus 4. Where this dimension is x plus 2 and this dimension is x plus 2, and the product is a perfect square. So it's only if the factors are the same. Only if you're working with a binomial squared. What would be the resulting trinomial? What do we call that? Reaching back now. What's this trinomial called if it's the result of squaring a binomial?
Quadratic expression.
It is a quadratic expression. It is a trinomial. It's a perfect square trinomial because it's the result of squaring a binomial. Perfect square trinomial right there. Boom. The product, a square. Oh, that's helpful to remember. Now, looking back at the examples that you did in number 2 and number 3, look at number 4. Can you see a way to factor trinomials of the form ax squared plus bx plus c without using algebra tiles? So you're looking for connections between your picture and the trinomials that were given and the binomials that were given. Are there any connections there? Is there a way to factor to get from the trinomial to the binomials without drawing it out like that? Here are some notes that can help us think about it before we move on to our examples. So here we go. When you expand, so this is looking back at expanding and distributing and foiling. When you expand two binomials, you add the two middle terms. And so just think of that this way. When you FOIL, F is on its own, L is on its own, but O and I get added up. You add the two middle terms. Okay? A simple example is right here. If we had two binomials, let's say 2x plus 3 and 3x plus 4, and we were expanding it, we were FOILing it, then we would do first times first. What's 2x times 3x? 6x squared. Then we do outside times outside. 2x times 4 is? Positive 8x. And then we do inside times inside. 3 times 3x? 9x. Good job. And last times last? 12. So here we have FOIL, and look at what happens to these terms. We add them up, right? So our final answer here would be 6x squared plus 17x plus 12. Notice the following pattern. Notice the following pattern. 8 plus 9 equals 17. And 8 times 9 is equal to, not 12 this time, right? It's not sum and product, but it's 6 times 12. So when we did sum and product, we said that the two middle terms would add to 17 and they'd multiply to just 12. But this time we're saying that they're going to multiply to 6 times 12. Well, where did that 6 come from?
Here in the beginning. 6 squared.
Yeah, the 6 comes from here. So now we're not just adding to the coefficient b and multiplying to the coefficient c, we're multiplying to the coefficient a times c. So it's still sum and product, but there's going to be an added step involved. So, in order to factor a trinomial in this form, ax squared plus bx plus c, we can work in reverse by replacing the middle term with two terms whose coefficients have a product of a times c. So, let's write that. When factoring a trinomial, should still all fit on the bottom of your first page there. When factoring a trinomial in the form ax squared plus bx plus c, replace the middle term and that's bx, replace the middle term bx with two terms whose integer coefficients, integer means it's a whole number, coefficient means it's the number that goes in front of the variable, whose integer coefficients have a product of a times c, so that's a times c, not a xc, and a sum of b. Again, so when factoring, that means we're going from a trinomial like this to the product of two binomials. And what we're going to do now is, instead of finding out what adds to b and multiplies to c, we're going to find two integers that add to 17 and multiply to a times c. So a times c here is 72. So we found two integers that add to 17 and multiply to 72, positive 8 and positive 9. So we split up this 17 into 8 and 9, and then, oh boy, what style of factoring can we use? If we have four terms, there's no common factor through all of them, but there is a common factor between the first two and the next two. What style of factoring is that? Factoring by grouping. Okay? So let's try a few in our examples. Again, we're going to be looking for a way to split this middle term into two integers that add to the middle term and multiply to a times c. Just one extra. Example 1, breaking up the middle term, factor if possible. So 1a is 3x squared plus 8x plus 4. Again, we're going to use sum and product. We know here that a equals 3, b equals 8, c equals 4, right? Because the standard form of our quadratic expression is ax squared plus bx plus c. So now if we go over here into our sum and product, the sum is still just b, but the product is going to be a times c. Okay? So the sum is just b, which is 8. The product is a times c, which is 3 times 4, which is 12. So now we're looking for two integers that multiply to 12 and add to 8. Well, let's get our integers, our factors of 12. 1 and 12, 2 and 6, 3 and 4, Now I'm at the top of the mountain, I'd be heading back down. I could also do all of these in negative, right?
26.
But we see the answer there. We have 2 times 6 is 12, 2 plus 6 is 8. So now what we're doing is not chucking them right away into our factors, we're only dividing our middle term. So we're splitting this into 2 terms. Instead of saying 3x squared plus 8x plus 4, we're going to say 3x squared plus 6x plus 2x plus 4. See how we have not changed the value of the expression at all. We just took 8x and said we're going to split it into 6x and 2x. Those add up to 8x. But now look at what we can do. The next step is to factor by grouping. So let's pull the common factor out of our first bracket here, our first binomial. 3x. If I pull 3x out, I'm left with a binomial. The first term, Paul, is just x, because if I take 3x squared divided by 3x, I'll be left with x. 6x divided by 3x, Emma? 6x divided by 3x. Very close, so 6 divided by 3 is going to be 2, and the x's just are going to cancel out, right? And we have an addition symbol in here we don't want to forget about, so we're adding our next part, and we're going to find the common factor. Tanner, what's the common factor between 2x and 4? Just 2, good job. And when I pull 2 out of the first term, Julia, I'm left with x. And Jonathan, when I pull 2 out of the last term, I'm left with 2. Now, if you've done it correctly, what should you notice?
But if you multiply them,
These two binomials are the same. Okay? Now, we still have 2 factors. We have 2 terms here. And each a term, they also share a common factor. The common factor is x plus 2. So I'll pull x plus 2 out of both of these terms. That's this term and this term. And when I pull it out of this first term, I'm left with 3x. When I pull it out of this second term, I'm left with 2.
you're not just using from the front, or do you have to pull them?
Example 1b, we're given 3x squared plus 2x plus 4. This is a trinomial, and we are going to try to factor it. So let's identify our parameters. What is a?
3.
A is 3. What is b? 2. What is c?
4.
So we need a sum of b, and we need a product of a times c. So sum of 2 and a product of 12. Good? So we're listing all of the factors of 12 until we find a pair that adds to 2. So we got 1 and 12, 2 and 3, sorry, 2 and 6, 3 and 4. Do any of these add to 2?
No.
Should I try our negatives? Negative 1, negative 12, negative 2, negative 6, negative 3, negative 4. Any of those add to 2? Since there is no pair of integers, since there is no pair of integers,
Did you say no, not possible?
you can in your homework, that satisfy these conditions, comma, it cannot be factored over the integers. So that means it might be able to be factored using decimals and fractions, but it can't be factored using the skills that we have. It can't be factored over the integers. In C, we're dealing with the trinomial 6x squared minus 5x plus 1. Can somebody please identify A, B, C for me? Vlad?
A is 6, B is negative 5, and C is 1.
Good. And Isaiah, that means we're looking for a sum of negative 5 And Julia, we're looking for a product of
6.
y.
A times C.
Good. So it's still a times c, but c is 1. So we've got 6 times 1. We're looking for a product of 6. Next step. Lindsay?
Find the factors.
All the factors of 6. 1 and 6. 2 and 3. Negative 1, negative 6. Negative 2, negative 3. Paul, which factors do you like? Good call. So we looked at 2 and 3. They do multiply to 6, and they add to 5, but we're looking for negative 5. So we're going to take negative 2 and negative 3. Now, does that mean I can just chuck those values into my brackets? No. Okay, all they're helping me do is to split this middle term. So now instead of 6x squared minus 5x plus 1, we have 6x squared minus 2x minus 3x plus 1. Now, I'm going to give you a hint here. It doesn't matter which order you put these in. Okay? In this case, both ways are pretty easy. In the last case, in example A, had we swapped them, we would have been dealing with fractions, but it still would have come out with the same answer. Okay? So it doesn't matter which order you put them in, but often it's smart to choose the order that you want. So I see a really easy factor, common factor between 6 and negative 2, and a really easy one between negative 3 and positive 1, so I wrote it this way. But there's also a really easy common factor between 6x squared and negative 3x, right? And a really easy one between negative 2 and positive 1. So no matter which way I do it, it's not that difficult, but always just look ahead and you can put them in whatever order you want. Okay, from here, when we group it, we want to make sure that we have a positive sign in the middle. So we're going to add these, but then our next bracket is going to be negative 3x plus 1. And what this makes sure that we do is this makes sure that we keep each sign with its corresponding term. So this allowed us to keep the negative sign with the 3x and the positive sign with the 1. Okay? Don't forget this step. So if you are left with this, don't group it this way. Okay? You need to add and then have a negative 3x plus 1, because adding a negative is the same as subtracting, right? So whether I have a subtraction here or I have plus negative 3x, those are the same. So that's how we do it in our grouping. Now when we take out our common factor, we're going to take out 2x, which leaves us with 3x minus 1. And we're going to be adding, but we're going to take out negative 1. And we're going to be left with 3x minus 1. Okay, good. This right here is plus a minus 1, so I can just make that negative 1. Now it's easier to see where our next grouping comes. We take out the common factor of 3x minus 1, and here it's getting multiplied by 2x, and here it's getting multiplied by negative 1. So our final answer then, our two binomials that multiply together to get our trinomial, is 3x minus 1 and 2x minus 1. Example 2 says trinomials with two variables. So example 2 says factor the following trinomial: 10x squared minus 3xy minus 4y squared. And you guys asked this question about your homework last night. And now we're going to get a lesson on how to do it. So we're going to factor this trinomial with two variables in it. So again, we're just identifying a, b, c in the same way. A is the coefficient in front of the first term, that's 10. B is the coefficient in front of the second term, that's negative 3. And c is the coefficient in front of the third term, that's negative 4. So now we need to find two integers whose sum is negative 3, that's b, and whose product is negative 4 times 10, or negative 40. So we're going to list all of the factors of negative 40. So in every one, there's going to be a positive number and a negative number, right? So we've got 1 and 40. Let's make one of them positive, one of them negative. And we also have it the other way, positive 1, negative 40.
Do you really have to?
We could skip down until we think we're getting closer to what we need. So let's say 4 and 10. Or 4 and negative 10 and negative 4 and positive 10. Then we have 5 and negative 8 and negative 5, positive 8. Do you see anything that might add to 3 yet?
8.
Yeah, so we're in the 8 and 5. Which one is going to be negative, the 8 or the 5?
Negative 8.
Yeah, the bigger number has to be because we're going to end up with negative 3 of them, right? So now again, we're just splitting that middle term. Okay, so go ahead and split that middle term. Now we have 10x squared plus 5xy minus 8xy minus 4y squared. Now what can we do? We can factor by grouping, okay? We can factor by grouping. So again, the same problem that we ran into last time, we're going to fix here. That gives us 10x squared plus 5xy grouped. And we're going to add negative 8xy minus 4y squared. And that allows us to keep our sign in front of the term. Common factor between 10x squared and 5xy?
5.
Don't forget your variables. Yep, 5x, which leaves us with 2x plus y. And over here, common factor between negative 8xy and negative 4y squared? Negative 4y. Good. So if you say 2, that's good too. But then keep going. Say, oh, now I'm still left with 4 and 2. Well, that's another 2, so it must be 4. Okay, let's pull this guy out. That leaves us with 2x. And if we pull negative 4y out of negative 4y squared, that leaves us with y. And again, you can see that you've done it correctly if both of these binomials are the same. And now we can pull out 2x plus y from both of the terms that we have, leaving us with 5x minus 4y. And that is the binomials product that equals our trinomial there. Example for lesson 5.5. We are again just asked to factor a trinomial, 16x squared plus 26x minus 12, but we also are going to identify quickly something that we can do before factoring it using sum and product, and that's if we look at these coefficients, we notice something about them. We notice that they are all even numbers, which means that each of them is divisible by 2, which means that we have a greatest common factor of 2 in all of our terms. So before I even start with my sum and product and start thinking about A, B, C, I'm going to pull out the common factor from each of these terms. So we're going to represent our trinomial as 2 times 8x squared plus 13x minus 6. Now the expression that I've written has the exact same value as the one we've been given, and if I want to double check that, all I have to do is distribute this 2 back into each term to show that I would have 16x squared plus 26x minus 12. But now I'm working with a much simpler trinomial. And the strategy is the same. We're going to use sum and product. So I have a sum of 13. I have a product of a times c, which is negative 48. And I'm looking for all the factors of negative 48 and hoping to find the one that adds to positive 13. So let's go up our mountain. We've got 1 and negative 48, as well as negative 1 and positive 48. We've got 2 and 24, negative 24, as well as negative 2 and positive 24. And I've got 3 and negative 16, and negative 3, positive 16. And now I've just written two integers that I know have a difference of 13. And I know I need to have positive 13, which means my bigger number is going to be the positive number. So we're working with these factors right here. So I'll leave my 2 out here. And my next step is simply splitting my middle term. 13x is now going to be represented as 16x minus 3x. Again, I can order these any way I want to, but it's going to be easier for me if I put the 16x first. If I group it with the 8 because they divide easily. And I have minus 3x minus 6, and they are going to divide easily. Now the same thing that we ran into last time we're going to run into here. I need to keep this negative sign with the 3x and this negative sign with the negative 6. So watch what happens here. I'm going to be using more brackets, so I'm going to throw a square bracket in here instead of the rounded bracket. I'm going to rewrite my problem. I know these are going to get grouped, and then I'm going to have plus negative 3x minus 6. And I maintain the square brackets. That shows that all of what's in here still has to get multiplied by 2 in order to maintain the value that we started with. Okay, let's factor out our common factors from each of our two binomials. So again, we've got our 2 out here. It's all getting multiplied by that. Here we can factor out 8x, which leaves us with x squared plus 2. Here we can factor out negative 3. So again, I'm just going to put negative 3 out, and that leaves us with x plus 2. And we can see that we've done it right if we can multiply it back. Negative 3x, yep. Negative 6, yep. And we have the same binomial here and here. Looks good. So our last step is inside the square bracket. The second last step, I suppose, is to take out our common factor of x plus 2. X plus 2 is being multiplied by 8x as well as negative 3. And because multiplication is commutative, I can arrange this any way I want, which really just means that I don't need these square brackets. All the square brackets are telling me to do is multiply these guys by each other before multiplying them both by 2. But again, because multiplication is commutative, it doesn't matter. I could actually do the 2 distributed to these guys, and then that answer distributed to these guys. So I can really just take away the square brackets, represent this as 2 times x plus 2, 8x minus 3. And now this trinomial actually broke into 3 factors. 1, 2, 3. Okay, thanks for watching. This told us how to factor trinomials in the form of ax squared plus bx plus c, where a was not 1. We said that instead of just doing sum and product with the sum of b and the product of c, we now have the product of a times c. And then we find our factors of a times c. That allows us to split our middle term, because they will add to the coefficient of the middle term. And then we can factor by grouping. Go ahead and try your homework problems. Please come to class with questions.